I'm good myself and you.
I'm also good. Yeah, it seems as others haven't joined us yet, but because of time, let me just start immediately. If they don't join, I'll send them the recording. All right. I think we have done enough about simultaneous equation.
Yeah.
It's time. It's time to move to other chapters, of which today I will have to start a chapter of trigonometry. So we're going to do what is called trigonometry. This chapter, let me put a star next to it because it's another important chapter which you're going to learn in mathematics. So we have trigonometry, of which I'll start by what is called the core ratios. So we must know how to deal with core ratios. So the core ratios that you deal with in the level of your study, the first popular core ratio or trig ratio, it's a sine. In this case, let me say sine theta. So sine, it's a trig ratio, and then theta is an angle. So if we have sine theta, we can then use right angle triangle. So right angle triangle, it must have a 90 degrees somewhere. It's either down here, here, or there. So in this case, you can see the 90 degree is down there. So you must have 90 degree if it is right angled triangle. So here we have 90 degree, of which if we have an angle down there, this side we can call it X, and that side we can call it Y, and this side we can call it R. This side of X is given a name. What do we call the X is the adjacent side, right?
Yes.
Is the adjacent side. And then what do we call that side of Y?
The opposite side.
Is the opposite side, definitely. And then this side of R
Hypotenuse.
is the hypotenuse. Don't forget that information. It's very important. So we have opposite, adjacent, and hypotenuse. So after having that, you can then be able to write sine theta, which is core ratio, in terms of these sides, the adjacent, the opposite, and the hypotenuse. So how can we write sine theta? Sine theta is given as opposite over hypotenuse, of which in this case, opposite is given as y, and then hypotenuse is given as r. So sine theta at all time, it must be equal to y over r. But this is the case only if we have right angle triangle. So it means we must have a 90 degree somewhere. Otherwise, if you are having a triangle which is not right angle triangle, like this one, where we don't have 90 degrees somewhere, we don't have to use the trig ratios. Né?
What do we use?
Yeah, it's not at your level of to know what we must use in order to deal with a triangle, which is not right angle triangle. You will never come across a question where we are not having right angle triangle because it's very sophisticated. There are rules which we're supposed to use, of which will only be introduced to those rules when you do grade 11 and grade 12. So otherwise, for grade 10, you don't go beyond that. So you can't solve triangle, which is not right angle triangle, like this. You will never come across this situation. Are we together?
Yes.
All right. You must get this right. It's very, very important information I'm telling you now, of which you must not forget that at your level, I'm repeating this because it's important. Whenever you apply the core ratios all the corratios, you must have the right angle triangle. If you don't have right angle triangle, you are not allowed to apply the trig ratios. So trig ratios, I'm referring to sine, cos, and tan. So the first one is sine theta. Sine theta is equal to opposite over hypotenuse, of which opposite is y and hypotenuse is what? Is I. Are we okay with the first trig ratio?
Yes.
All right. Buchilo is with us. So let me just find out from Buchilo. Are you fine with the first trig ratio I indicated on the board just now? All right. Let me explain again for Buchilo. Today we're going to focus on this chapter of trig ratio. I mean the trigonometry. And we're starting with a first section of corratios or trig ratios. Is the same thing. So we have three different corratios that I'm going to introduce to you, of which you do at your level. The first one is called sine. The second one is called cos. The third one is called tan. So all these three trig ratios, you only use them when you have right-angled triangle. Right-angled triangle. Already reason on right-angled triangle, we don't apply these trig ratios like the way they are. They must be transformed for them to work. So, but it's not at your level where we're going to transform the trig ratios. Or it's going to apply a triangle in a right-angled triangle. And you find out if on process uri divide a triangle you know apa the right angle triangle re se divisa re divide a triangle you know apa noni re se divisa uri a triangle you know on the right angle triangle
Because even in a right angle, it never equal to 90 degrees.
very true. We must be given this angle of 90 degrees. That's what we know, Uri. That's how we know, Uri. The triangle that is given is right angle triangle. Otherwise, if we don't have 90 degrees somewhere between these three angles, it's not right angle triangle. So it's only when it's a right angle triangle where we can apply the what? The trig ratios. So the first trig ratio, which you must not forget, is called sine. So sine theta, sine is a trig ratio, and then theta is an angle. So sine theta is equal to opposite side divided by hypotenuse side, of which opposite in that case is indicated as 1, and then the hypotenuse is indicated as r. So is sine theta equal to y over r. Which you wrote terms. Hello? Wrote it? Okay, that's the first one. Let's go to the second one. Okay, let me just find out if you know what is going to be the ratio of cos theta. Cos theta in a minute, if you know.
Adjacent over hypotenuse.
Adjacent over hypotenuse. Well done. That's very true. Of which in this case, adjacent is indicated by x, and then the hypotenuse is indicated by r. Cos theta is equal to x over r. All right, then the last one is tan theta. So tan theta is given by opposite over adjacent, of which in this case, opposite is y, adjacent is x. So these are the three trig ratios which you must remember at all time. So these are the three trig ratios which you must remember. I believe we all understand everything about these three trig ratios. So now we can go to the Pythagoras. This is the first one, the corratios or the trig ratios. And then the second one is what is called the Pythagoras theorem. Have you heard of Pythagoras theorem before? All right. What is the formula for Pythagoras theorem?
R squared equals to X squared plus Y squared.
Very true. So it's X squared plus Y squared equal to R squared. So Jambazo,
What's that?
is this side
What's
squared?
that?
Yes.
Phone yangu yako itaichua kabisa.
Oh, okay. No, it's okay. Let me pin the screen so that it doesn't go. Yeah, I believe now it's fine. So Rina, Pythagoras theorem in X squared plus Y squared, which is equal to R squared, of which in this case X is the adjacent, Y is the opposite, and then the R in this case is the hypotenuse. So this is called the Pythagoras theorem. Again, Pythagoras theorem, it works when we are given a right angle triangle. If it is not right angle triangle, we can't use the Pythagoras theorem. Right? All right. So now let me go to the third important, of which is called the identity. Have you heard of the identities before? Amongst you, is there any one of you who have heard about what is called the identity? All right. It seems this is a new thing to you. So identity, in this case, is the first identity which you must know is the identity of tan theta, which is equal to sine theta divided by cos theta. So in other words, this tan theta we have up here is the same as dividing sine theta and what? And cos theta. Tan theta is equal to sine theta divided by cos theta. Let's prove that so that you can have confidence of why we say tan theta is the same as sine theta divided by cos theta. Let's prove. So now we're given tan theta, which is equal to sine theta over cos theta. So we can start with left-hand side. So left-hand side, we are given tan theta, which is tan theta in this case, which is equal to tan theta on the trig ratios, we know it's equal to sine over 1. So that is on the left-hand side, right? Then now we go to the right-hand side. What are we given on the right-hand side? Remember, we are proving that left-hand side is equal to right-hand side. So now we know left-hand side is y over x. Let's now deal with right-hand side. Right-hand side is given as sine theta over cos theta. So we want to find out if indeed sine theta over cos theta is the same as y over x. We know what is sine theta in terms of x, y, and r.
Y over R.
Is y over r, and then all this divided by cos. What is cos in terms of x, y, and r?
X over R.
X over r. So you can see we have 3 divisions here. Is there any one of you who can tell me what do we do in a situation where we have many divisions? What do we use in order to deal with many divisions? We have to use what is called a reciprocal theorem. Ne? You must not forget about that theorem. It's called reciprocal theorem. So let's use the reciprocal theorem on this question. So if we use the reciprocal theorem, we're going to have y divided by r. Then this big division here, we must change it to multiplication. So, but when we change it to multiplication, the positions of terms on the denominator, they changes the position. So une havana x goes after r, une havana r after x. Zombo ziko to change a position. So in this case, zombo the r divided by what? Divided by x. Roshimsa reciprocal theorem. Let me write it here so that you don't forget. Reciprocal theorem. So big division reaching come application. In a reaching come application, R rate the wanganta X yavanga pass. And then from there, R na R is the cantlan rasorana Y in a dividend na X. Generate the Y each divided na X is the same as what? As left hand side. So therefore, left hand side is equal to right hand side. So now we prove this identity that tan theta is equal to sin theta over cos theta. We proved that indeed left hand side, which is y over x, is the same as right hand side, which is x over y over x, which means tan theta is equal to sin theta over cos theta. Are we together on that one?
Yes.
Wuchiro, are we together?
Yes.
All right, let's move forward. So that is the first identity. I'm going to give you the second identity again. So the second identity is given as sin squared theta plus cos squared theta. It's always equal to 1. Sin squared theta plus cos squared theta is always, all the time, it is equal to 1. It's another important identity. Remember, I'm introducing identities here. So this is another important identity which you must not forget. Myself, I believe in proving. Actually, mathematics is about proving. Whichever statement that you come across in mathematics, you must be able to prove or justify that what you're getting is correct. So let's prove that indeed sin squared theta plus cos squared theta is equal to 1. So we have sin squared theta plus cos squared theta is equal to 1. So it means we must take a left-hand side here. We're going to work with left-hand side until we prove that it's equal to right-hand side, which is 1 in this case. So we have sin squared theta plus cos squared theta. Already we know what is sin squared theta in terms of x, y, and r. Can you tell me again, what is sin theta in terms of x, y, and z?
Y over R.
You see, these trig ratios are important. We use them to prove these two identities down here. We are also using them on the Pythagoras. You will see how these two they link. Okay, so now we are having sin squared theta, which is y over r, but in this case we have a square. Is this square that we have there? And then cos squared theta. What is cos theta?
X over R.
X over r. So now it means we are allowed to now write this as y squared over r squared plus x squared over r squared. We have a square there. It's from there. Then now, if denominators are the same, underline this. If denominators are the same, we are allowed to add the numerators. So let's add the numerators. If we add the numerators, we're going to have x squared plus y squared, all divided by r squared. Why? Because denominators are the same. We have r squared here and we have r squared there. So it's x squared plus y squared divided by r squared. But from Pythagoras theorem, we know what is y squared plus x squared plus y squared. Can any one of you tell me what is x squared plus y squared from Pythagoras theorem? X squared plus y squared is equal to what from Pythagoras theorem?
R squared.
It's equal to r squared. So it means where we have x squared plus y squared, we replace by r squared, and then we divide by r squared. R squared divided by r squared is what?
1.
It's 1, of which is the one we have on the right-hand side. So then now we proved in this case that left-hand side is equal to right-hand side. Remember, we were proving that this identity we have down there is correct. Do you all see that? I'm giving you important information here. You must not forget this information. Okay, let me not give you more new information. We just need to apply what we have on the board. So let me send you the question that I will have to do with you on the board. This question is from a previous question paper. All right. Maybe before I go further, let me also introduce just one more thing. It's called reduction angle, because I think we can't do much without having reduction. So let me wrap all these things and then introduce the reduction angle. Have you heard of reduction angle before?
No.
Is the first time you are hearing about reduction angle, né?
Yes.
All right. Once you understand everything that I'm teaching you today, you must not forget this, because once you understand it, you are going to pass trigonometry for grade 11 and trigonometry for grade 12. All these things, they don't change. They will just add few things, but nothing is going to change in mathematics for grade 11 and for grade 12. This is what is given. Can any one of you tell me the name of these lines I drew on the board? What do we call this in mathematics?
Cartesian plane.
Is the Cartesian plane. Are we together?
Yes, yes.
Yeah, that is the Cartesian plane. You must not forget the name of this thing. It's very important. So it's the one which is going to assist us to do what is called the reduction angles. The reduction angles. So now down here we have 0 degree. We are given a 0 degree there. If you know about this, can you tell me what angle are we going to have up there? If this is a Cartesian plane, what angle are we going to have up there? So if
the angle or the degree?
Angle or the degree is the same. Angle and degree is the same. So what degree do we have up there?
90.
Is 90 degree. Yes, very true. And then here, what angle do we have?
180.
It's 180 degrees. And then down here, what do we have?
360.
Is 270, right? So 360, we have it exactly where we have 0. It's after rotation. So if you go from 0 and then you rotate and go back straight to 0, we have rotated 360 degrees. So these things, they form shape. Like for example, if you rotate from 0 to 180 degrees, which shape does it form? It's a straight line, eh?
Yeah.
So if it rotates from 0 to 360, which shape does it form? It's a cycle, which is a revolution, eh?
Yes.
Yeah, don't forget that information. Remember, we are focusing on what is called the reduction angle. I'm going to give you a reduction angle on these blocks. So we have 4 blocks here. So on the first block, we call it first quadrant. Don't forget the name of this thing. So it's called first quadrant, and then this is called second quadrant. And then that is called third quadrant. And then that is called fourth quadrant. Are we together?
Yes.
Yes. So then on the fourth quadrant, we want to know which trig ratios are positive. How many trig ratios did I introduce to you? There are 3, ne?
Yes.
So it's sine, it's cos, and it's tan. So we want to know which trig ratios are positive on this first quadrant. So I'm going to give you that information. So now on this first quadrant, we have angle of 90 degrees, which is the maximum angle. But along that quadrant, we can have 90 degrees and any other angle below 90 degrees. We can have 60 degrees, we can have 70 degrees on this first quadrant. But 100 degrees is not within that quadrant because we know rotating from here to there is 90 degrees. Therefore, if we talk about 100 degrees, it no longer belongs to this quadrant, but it belongs to which quadrant? 100 degrees,
So
it belongs to which quadrant?
second quadrant.
To the second quadrant, yes, take note of that. So then now all angles which are within this first quadrant, we must be able to define them mathematically. So this is how we define them. We say maximum angle, which is 90, minus any other angle which is within that range. So that defines any angle which you're gonna find on this first quadrant. We do exactly the same thing on the second quadrant. So on the second quadrant, we can say 90 degrees plus any other angle which is on the third quadrant. Why do we say 90 plus? Because it's this angle here, which we know is 90 degrees plus any other angle which is gonna be on the second quadrant. Are we together?
Yes.
If you are following, which other angle can we have on the second quadrant? It's not just one angle we have on that. So we have the first angle, which is 90 plus theta, and then which other angle can we have on the second quadrant?
180.
Very true. It's 180 minus theta. Why it's 180 minus, not plus? It's minus because 180 is the maximum angle, right?
Yes.
So it's 180 minus theta. And then here we say 90 plus because 90 is the minimum angle. Then we have to add in order to go to the maximum. So which angles do you think we can have on the third quadrant?
180 plus theta.
180 plus theta, very true. And then which other angle do you think we can have?
270 minus theta.
Wonderful. I'm very happy to see that you are following. And then on the last quadrant, which angles do you think we can have?
270 plus theta.
Is 270 plus theta, and which other one?
360 plus.
360 minus, right? Minus theta.
Oh yeah.
Yeah. Then on the first quadrant, we can also add another angle. So it's 360 plus theta. And again, on the fourth quadrant, we can add another angle. It's called minus theta. So let me explain this important angle, minus theta. Why do we have minus theta on the fourth quadrant? Because you can see in this case, we are taking anti-clockwise direction. All these angles, we're getting them by taking the anti-clockwise direction. So now what if we are taking the clockwise direction? When we take the clockwise direction, that's when we have a negative theta. Because we know angles below, angles below the x-axis, they are negatives. And then above the x-axis, they are what? They are positive. So that's why we have minus theta. Are we together? Are we together?
Yeah.
All right. Let me just find out if there is any one of you who did not understand what we have done up to so far.
Yes.
All right. Johnson, she joined just now. I'll just summarize the reduction angle for her, but other things which we have covered already, she must, I will send a link so that she follow from there, from the link. So otherwise, this is what is called the reduction angles, of which all angles which are inside these quadrants, they are like this. They cannot be tampered with. So you must know about these angles that we have on the reduction angle. But from there, there is something which I will want to add, which is important. It's called the core ratios from reduction angles. The core ratios from reduction angles. So now, let's just give as an example, we have sine 90. Let me also mention that core ratios are 90 degrees and 270 degrees. These are what is called the core ratios, because at 90 degree and 270 degree, sine, cos, tan, they change. Sine, cos, tan, they change whenever we have 90, whenever we have 270. But if we have 180, we have 360, sine, cos, tan, they don't change. So let me show you what I'm talking about. Let's just take, for an example, we have sine 90 degrees minus theta. Let's say we have sine 90 degrees minus theta. So sine 90 degree minus theta, you must first investigate where do we have 90 degree minus, or on which quadrant do we have 90 degree minus? Can any one of you tell me from this reduction angle, where do we have 90 degree minus?
The first quadrant.
It's on the first quadrant. So, and on the first quadrant, let me emphasize this again before I explain further. It's only, it's all trig ratios which are positive. Sine, cos, and tan, they are all positive on the first quadrant. But on the second quadrant, it's only sine which is positive. It's only sine which is positive. So it means if we have sine of 90 plus theta, the answer we're going to get is positive, because it's what? It's sine. And then on the third quadrant, it's only cos, which is positive. It's only, in this case, it's tan. It's tan, which is positive on the third quadrant. And then on the last quadrant, which in this case is fourth quadrant, we only have cos that is positive. I will explain that in detail so that you understand what I mean. So let's check what we have here. So we have sine of 90 minus theta. So we must investigate, where do we have 90 minus? 90 minus is on the first quadrant. On the first quadrant, which trig ratio is positive? On the first quadrant, which trig ratio is positive?
All of them.
All of them. Therefore, it means the answer we need to get here is positive. But now, let me show you something here. If we have 90 and 270, sine changes to cos all the time. So you can see in this case, we have 90 there. So therefore, because we have 90, the answer we get, it will be positive. Why it's positive? Because we are in the first quadrant. But now the sign is going to change to cos. Why sine is changing to cos? Because we have a core ratio of 90 and 270. In this case, we have 90. So therefore, that's why we have cos of theta. You no longer write 90 minus, because 90 minus, you already use it to investigate the quadrant. So we're going to check 90 minus. All right, network is misbehaving, but I think I'm back now. So I was still explaining that 90 minus is on the first quadrant where sine is positive. But because it's core ratio of 90, sine must change to what? To cos. So that's why we have cos of theta in this case. So sine 90 minus theta is the same as cos of theta. Are we together?
No.
Let me explain the second one. I know I'm giving you more information, but let me explain the second one so that you see what I'm talking about. For example, let's say we have cos. Yes. Okay, let me adjust that just now. I think it's fine now. So let's investigate cos of 90 degrees plus theta together. So what do we do in a situation where we have cos of theta, cos of 90 plus theta? So in that situation, we must go and check, where do we have 90 plus on this Cartesian plane? Where do we have 90 plus?
Second quadrant.
It's on the second quadrant. And on the second quadrant, which one is positive?
Sine.
It's sine. But what do we have here? On this quadrant?
Cos.
It's cos. Therefore, that simply tells us that we're going to get a negative. So after getting negative answer, we then go and check which angle do we have here. If we have 90 or 270, what is going to happen on cos? Cos is going to change to what? Cos is going to change to sine. Why? Because we have 90 there. All right, let me give you an example. So those are the correlations. We can do as many correlations as possible, but I think 2 correlations are enough. Let me just go on this one. I just want to find out if you are following. Let's say we have cos of 180 degrees minus theta. Can any one of you tell me, where do we find 180 minus? Where do we find 180 minus on the Cartesian plane?
Second quadrant.
It's on the second quadrant. And then on the second quadrant, which one is positive?
Sine.
Which one is positive?
Sine.
It's sine. Yes, very true. But in that case, what do we have? We have
Can't see it.
cos, right? So it means we are going to have a negative in this case. So it's 180 minus, which is on the second quadrant. And now we know on the second quadrant, it's only sine, which is positive. But here we have cos. Therefore, it means we are going to have a negative. And then after having that, we go and check here. Do we have co-ratio in this case? Is 180 a co-ratio or not? Remember the co-ratio, eh? Co-ratio are 90 degrees and 270 degrees. Is 180 a co-ratio? It's 180 co-ratio or not? It's not a co-ratio, né? Because co-ratios are 90 degrees and 270 degrees. Co-ratios, they change cos to sine and they change sine to cos. But in this case, we have 180 degrees. Therefore, it means cos of 180 minus theta is minus cos theta. So cos doesn't change in this case. Why cos is not changing? Because 180 is not what? It's not a co-ratio. All right, let me not give you further more information because we still have some days to work on more sections of trigonometry. So let me go straight to few questions that we can do for the day. Né? Can we go to the questions? Are you ready for the questions?
Yes.
All right. So I'll just choose simple questions for you so that we don't start with complicated things. So my first question to you is, this triangle we have on the board right angle triangle? Is the triangle we have on the board a right angle triangle?
Yes.
How do we know it's a right angle triangle?
Because it has a 90-degree angle.
Because we have 90 degrees down here. Are we together? These are the questions.
Yes.
The first question, it says, write the following. In terms of A, B, and C. So the first question, we have cos theta. The second question, we have tan theta. The third question, we have sine of 90 minus theta. This will be the only questions that I'm going to do with you today. After finishing with those, I'm going to send you homework to do. Let's start with cos of theta. I believe you remember how we can assess cos of theta in terms of hypotenuse, adjacent, and opposite. How can we write cos of theta in terms of opposite, adjacent, and hypotenuse? Wuchiro, how can we have? Wuchiro, how can we write?
B or
Barry,
How can we write cos of theta in terms of adjacent, opposite, and hypotenuse? Cos of theta is adjacent over what?
hypotenuse.
Over. And what is adjacent from these values that you are given there?
B.
Let's check where we have an angle. So the angle is here, right? So this side, is it opposite or adjacent to this angle, theta? Is it opposite or adjacent to angle theta? So adjacent, it means it's below theta. Opposite, it means it's opposite side to theta. Is A opposite or adjacent to theta? So in this case, A is opposite to theta, and then B is what? It's adjacent.